Hello, my dear student. Last time you all studied when current is moving in a conductor, it generated magnetic field around it. Today, you will be studying that if a current carrying conductor is kept in magnetic field. So here we will be studying the interaction between magnetic field generated by the current carrying conductor and the magnetic field produced by the magnet. So we will see what is and how is the interaction. Second, you will be understanding Fleming's left hand rule, and then you will see or understand the working of electric motor. Now, when we switch on fan rotates, or mixer grinder grind the spices and chutney, or your laundries are washed by washing machine. All these electrical appliances work on electrical energy. But how can a small amount of current can rotate such a heavy appliances? Have you thought of it, student? Well, the answer lies in when a current carrying conductor is placed in a strong magnetic field, it experiences force. And this force leads to rotation of current carrying conductor. Let's see with this a little activity. In this experimental setup, in this diagram, you can see there are two stands, one tied with magnet and another tied with a copper wire. Here, circuit you can see it is completed by applying a key and a cell to give the current. When the current starts to flow in the conductor, that is copper wire, there is some movement in the copper wire which is down. You can see here the direction of magnetic field is from north to south. So whenever current flows through the conductor, in the presence of magnetic field, a force is exerted on the conductor. So the conductor starts to move in a particular direction. If the direction of the current is reversed, the direction of force also get reversed. Also, the force will be maximum if the current is perpendicular to the direction of magnetic field. Just think about it. What if you keep the direction of current in one direction, but the magnetic poles are changed? That means magnetic field will be changing. Do you still have the same result? Take some time and think about it. Well, if you haven't, then it is okay, as the direction of this force depends on both. That means direction of the current as well as the direction of magnetic field. So the force or the motion or the movement of the conductor will be depending on the direction of current as well as direction of magnetic field. Now, after learning this, how we can find in what direction this force will be applied? If some appliances will be given or some setup will be given to you, how you will come to know that where the conductor will move? So for this, we have a rule which is given by the scientist Fleming, and hence we call this rule as Fleming's left hand rule. So you have to use your left hand. As I am explaining you, try doing it by your own. According to this rule, the left hand, the thumb of your left hand, index finger and middle finger, okay, so thumb, index and middle finger, you have to stretch in such a way that all three fingers are perpendicular to each other. You can try it out, student. Now remember this word FMI. for more information. Very popular in social media. FMI, where your thumb points to the force, that means where the conductor will move, that will be given by your thumb. M means magnetic field, that will be the direction of magnetic field. And your middle finger will be I, that means current. Current is represented by letter I, so that is why I. So, if your index finger points towards magnetic field, that is from north to south, your middle finger or central finger is pointing towards the direction of flow of current, then the direction of the thumb is the direction of force on the conductor. That means that will be the movement of the conductor in that particular direction where your thumb is showing. Come on student, try like this. Take your time, it will require little practice. Now let us understand how electric motor works. As you studied, a current carrying conductor, when placed in a strong magnetic field, experiences force. And this force leads to rotation of the conductor. Yes, the force that conductor experiences will rotate the conductor. Now, in our day-to-day life, an electric motor is a boon. It is used in many appliances like fan, refrigerator, mixer, washing machine, computer, pumps, etc. Yes, that all work on the principle of electric motor that you are now going to study and understand. So, what is this electric motor? Well, it is a device which changes electrical energy into mechanical energy. So, your electrical energy is getting converted into mechanical. Some work is being done. Coming to its working, it consists of a rectangular loop of a copper wire having a resistive coating so that current doesn't get wasted, which is placed between two strong magnet, north pole and south pole, such as a horseshoe magnet also, in such a way that side AB and CD are perpendicular to the direction of magnetic field. So with this setup you can understand that the coil is rectangular. It is easy to understand here, like in if I keep it in rectangular, that is why in your book also it is given. So side AB and side CD you have to focus, and it is placed perpendicular to the magnetic field, that is north to south. Now the two loops, I will call this conductor as a loop, okay, because the complete setup is making a loop. The two loop ends connected to two halves. You can see here X and Y. These are called as split rings. I will tell you its use in some times, don't worry. These two half split rings have resistive coating on their inner surface, again so that the current doesn't get wasted or doesn't just come out, and it is tightly fit onto a axle, and the outer conducting surface is in contact with two stationary brushes, okay, something like this. You can understand from here. When circuit is completed and current flows in branch AB, that is from E, X, A, B, okay, since the direction of magnetic field is from north to south, according to Fleming's left-hand rule, force exerted on the loop AB is in downward direction. As your thumb will point downward. You can pause the video here, student, and try. First do it in CD loop. It will be easy for you to do. You point your all three fingers in perpendicular direction and try to understand where your thumb is pointing. So see that where current is flowing, it is flowing in downward direction. So point your central finger or middle finger in downward direction. Magnetic field from left to right, that is from north to south. So where your thumb is pointing, upward. Correct? So CD will experience upward force and AB will experience downward force. You can see here I have small video made for you. Now this loop ABCD starts rotating in anti-clockwise direction. Okay? When AB going downwards and CD coming upwards, you can see after completing half a rotation, you can think that this loop CD has come to AB side and AB has gone to CD side. So, where force will act now? Now I'll tell you the working of split rings. When the loop ABCD is rotating, due to the force acting on them, the axle and the half split rings X and Y are also rotating with them. And hence, now the current will flow in the direction of DCBA. That means first the current was flowing from A to B, now it will move from D to C and similarly from B to A. So that is why DCBA. So you can understand the loop, when taken half a rotation, it interchange, the current is still flowing in the same direction, that is from down to up in clockwise direction. So loop DC will experience which force now? Downward force. And loop BA will experience upward force. And that happens continuously. And hence the loop continuously rotates in anti-clockwise direction. Anti-clockwise, opposite of the clock direction. Here, point to remember, student, after every half a rotation, current in the loop is reversed and loop and axle continues to rotate in anti-clockwise direction. Current in the loop is reversed, okay, loop. So, A to B it was going, now D to C it is going. But the direction of current which is coming from the cell is same, okay. So, don't get confused there. Well, brushes are just in contact with half split ring. They don't move with the split rings or axle, so that it can maintain the continuity of current in this circuit. So something like this. Students, we could also rotate the loop in clockwise direction. Just you have to change the direction of magnetic field and the current in the loop. Try it out. I know you will be able to understand. Let me know in comment box, have you done or what was your result? Well, we have ended the working of electrical motor. All the commercial motors run on the same principle, but practical change are made in their construction. So you will learn it later in higher classes. And now this is what you have studied today, and I'll leave you with this. Thank you, students.